Hi, I'm Sanjana Reddy, a machine learning engineer at Google's Advanced Solutions Lab. Welcome to the lab walkthrough for Transformer models and BERT model. In this lab walkthrough, we'll be going through classification using a pre-trained BERT model. You'll find the setup instruction in our GitHub repository. Let's get started. In order to work on this notebook, you'll need to log into Google Cloud, go into Vertex AI, and click on Workbench. Make sure that you have a notebook created. Once the notebook instance has been created, click on Open Jupyter Lab. Once you've followed the instructions in our GitHub repository, navigate to Classify Text with BERT. In this notebook, we're going to learn how to load a pre-trained BERT model from TensorFlow Hub and build our own classification using the pre-trained BERT model. We'll learn how to train a BERT model by fine-tuning it. Before you get started, note that this notebook requires a GPU because the training does take quite a bit of time. When you open this notebook, there is a setup instruction in order to set up a BERT kernel to install all the required libraries for this notebook. For this notebook, we're going to be using TensorFlow and TensorFlow Hub, TensorFlow Text, which is required to pre-process the input for the BERT model. You can see that I'm checking if a GPU is attached, and I see that I have one GPU attached to this notebook. In this notebook, we're going to train a sentiment analysis model to classify movie reviews as either being positive or negative based on the text of the review. We're going to be working with the IMDb dataset that you can download from this URL. Once we have downloaded the dataset, we can examine the data to see what's in it. We see that we have 25,000 files that belong to two classes, positive and negative, and we're going to be using 20,000 files for training and the remaining 5,000 for testing. A sample of this dataset shows you the movie review over here and an associated label. So for the one over here, we see that the label that is associated is negative, and the one below here, it's positive. Once we've examined our dataset and we're happy with it, we're going to load a pre-trained BERT model from TensorFlow Hub. TensorFlow Hub offers multiple different variations of BERT models in all different sizes. We're going to use a small BERT for today's notebook. So this BERT model has 4 different layers. It has 512 hidden units, and it has 8 attention heads. For every BERT model that we load from TensorFlow Hub, it is associated with a corresponding preprocessing model. You can find the corresponding preprocessing model on TensorFlow Hub as well. We're going to examine the preprocessing model. So we're going to load the preprocessing model we see in the previous step. And we pass a sample text over here. So we just pass, "This is an amazing movie," and we're going to examine the output. The preprocessing model gives us multiple outputs. The first is the input word ID. The input word ID is the ID of the words in the tokenized sentence. The preprocessing model also provides us the masking for each word. Every sentence is converted into a fixed length input, and it masks words that are not valid. So once we have preprocessed our input text, we can use the loaded BERT model from TensorFlow Hub. In this particular cell block, it doesn't really make any sense because we've not trained the model. This is just a random list of numbers at this point. But once you pass the preprocessed text into this BERT model, you get certain embeddings. So in order to define our classification model, we start with an input layer. The input layer takes the raw text as input, passes it on to the preprocessing layer for preprocessing that converts it into token IDs, word IDs, and mask IDs. The preprocessed words are then passed to the pre-trained model. There is an argument here called trainable. Trainable here determines if you want to fine-tune the pre-trained model using the new data that you're training with or not. In our example, we are setting trainable to true, which means that we're going to update the initial weights of the pre-trained model. Your decision to set this to true or false depends on two things: whether you want to update the weights, and second, on the size of your dataset. If you have a relatively small dataset, it is recommended to set this to false so that you're not introducing noise into the pre-trained weights. But if you have a large enough dataset, you can set this to true. Once we have our pre-trained model, we pass it through a dense layer to get probabilities for each of our classes. This is what the output from the model is going to look like. The output is going to be a probability of whether this particular sentence is positive or negative. Since we're working with a binary classification problem, we're going to use binary cross-entropy as our loss function, and the metric to optimize for is going to be binary accuracy. We're initializing our training by defining the optimizer. In our case, we're using Adam, which is a popular choice for neural network models. Once we've initialized the training, we can start training using model.fit. We can pass the train dataset and the validation dataset and the number of epochs that we want to train for. Once a model has trained, let's evaluate the performance of the model. So in our case, we see that the model achieved an accuracy of 85%, which is pretty decent considering we only trained it for 5 epochs. You can potentially plot the accuracy and loss over time in order to visualize the model's performance. We see that the training loss is going down, and we could work on our validation loss a little bit, but for the sake of demonstration, we've only trained it for 5 epochs. Once you're satisfied with the model that you've trained, you can save the model using model.save. Model.save exports your TensorFlow model to a local path. So the export path in this line is going to be a path in your notebook instance. Once you've saved your model, you can load it to get predictions. So in this example, we have, this is such an amazing movie, this movie was great, the movie was okay-ish, the movie was terrible. And we get predictions for each of these sentences based on the model that we have trained. If you would like to take this further and deploy your model on Vertex AI to get online predictions, you could take the locally saved model and export it to Vertex AI. In order to do this, you need to check the signature of the model to see how you can pass predictions to the model. The signature of the model shows you what is the first layer that is taking input. So once we have the locally saved model, we are going to push the model to Vertex's model registry using these commands. In order to put the model in Vertex's model registry, you need to ensure that you have a Google Cloud Storage bucket, and these lines over here let you create a bucket if it doesn't already exist. We're going to copy the locally saved model using gsutil.cp, which takes the locally saved model from the export path and puts it in the Google Cloud Storage bucket. Once the model is in the Google Cloud Storage bucket, we're going to upload it to Vertex AI's model registry. We're using the Python SDK in this case, so we have aiplatform.model.upload, which takes the model from Google Cloud Storage bucket and puts it in the model registry. Once the model has been uploaded, we're ready to deploy the model on Vertex and get online predictions. In order to do this, we can use the Python SDK again. So we can use uploadedModel.deploy, which is a function that is going to do two things. One, it's going to create an endpoint, and 2, it's going to upload the model to this particular endpoint. So you can see here that it's creating the endpoint, providing you the endpoint location, and then once the endpoint has been created, the model is deployed to this endpoint. This step is going to take around 5 to 10 minutes when you run through your notebook, so just don't worry if it takes too long. Once the model has been deployed to the endpoint, you're ready to get predictions from this endpoint. So you can create an instance object. So using the signature of the model, we know that the name of the first input layer is text. So we're going to pass our review text to this particular key. We create this instances object that is going to be passed to the endpoint.predict function. And the endpoint.predict function is going to take this instance and it's going to give us predictions. So we can see for our first instance, I love the movie and highly recommend it. We have a prediction of 0.99. For it was an okay movie, in my opinion, we have 84%. And for I hated the movie, we have 2%, which means it's a negative sentiment. So this is how you can create a classification model from a pre-trained BERT model and then deploy it on Vertex to get online predictions.